rationalizing the denominator when you have one term. A monomial, or one term, will take care of one term. If you have one term, you're going to use one term to get rid of it. It's one on one. One kills one. So in this case, I have 1 over the square root of 3. I want to make it a perfect square in the denominator, so I'd multiply by the square root of 3 over the square root of 3. That turns the denominator into the square root of 9. 1 times the square root of 3 is the square root of 3. Square root of 9 is 3, so you get the square root of 3 over 3. Now, our problems in our book are much more complicated than that, unfortunately, but the process is the same. I have a monomial. I am going to multiply it by a monomial. But what I do to the denominator, I must do to the numerator. This is a 6 to the 1 power. In order to remember, the index is 2, so that means I need to have exponents that are multiples of 2. That means if I've got a 6 to the 1, I'm going to multiply it by a 6 to the 1 because it gives me a 6 to the 2. So the numerator becomes the square root of 5 times 6 to the 1. The denominator becomes the square root of 6 to the 1 times 6 to the 1. Well, 6 to the 1 is just 6, so the numerator becomes 30. The denominator becomes the square root of 36, which is the square root of 30 divided by square root of 36 is 6. Now the radical's in the numerator, not the denominator, which is what the goal is. Now I'm dividing by 6 instead of the square. Can you imagine what a nightmare that would be? Divide this square root of 6 into the square root of 5. You're going to have something to 9 decimal places divided into something to 9 decimal places. Talk about something that would not be fun to do. Now you've got a single number divided into something with 9 decimal places. Makes it much simpler if you have to do it by hand. But we don't. We have calculators. We say with a smile. Except when you get something like this, you can't use your calculator because the denominator has an x in it. I'm dealing with a square root, so and a monomial. If it's one thing, you use one thing. And I need to have, this is a 3 to the 1 and an x to the 1. I need a 3 to the 2 and an x to the 2 because the index is 2. I'm dealing with square root. So that means I need to multiply by a 3 to the 1, which gives me a 3 squared, and an x to the 1, which gives me an x squared. But what I do to the denominator, I must do to the numerator. This is going to be the square root of 30x in the numerator. In the denominator, it's going to be the square root of 3 squared x squared, which is the square root of 30x, and the square root of 3 squared x squared is 9x squared, and the square root of that is 3x. Now the radical's in the numerator instead of in the denominator.
Can't we take the 3x and make it?
Remember, we can't bring anything inside the radical that's not already in there. So I can't reduce it down unless I can take it inside. And I can't take it inside because it's outside. So it would be nice, but if we're under the radical, the answer would be yes. If that were a square root of 3x, you can then take it inside and simplify. But it's not a square root of 3x. It's just 3x without the radical, so you can't do it. Now here's the toughest of the concepts. I'm now dealing with cube root. That means the exponent has to be a multiple of 3. So I'm still a monomial, so I'm going to multiply by one thing, but I'm dealing with cube root. I've got a 2 to the 1 power. Because the index is 3, I need a 2 to the 3. If I have 1, 2, how many additional 2's do I need? I need 3 of them, right? I already have 1. I would need 2 more. That makes the denominator the cube root of 2 cubed, and the numerator 5 cube roots of 4. Five cube roots of 4, and what is the cube root of 2 cubed? Cube root of 2 cubed is? Well, cube root of 8 is? 2. So the cube here and here cancel each other out, and you just get 2. Just think about finding just the cube root of 4 by hand. You're multiplying things 3 times. Yes?
Can we multiply 4 locally? Can we see here?
Yes. Yes. Oh, okay. Now again, this is a monomial, so I'm going to multiply by the fifth root, because that's what it is. What am I going to do? This is a 2 to the 1. How many more 2's do I need? 4. I need a 2 to the 4th. 2 to the 4th, that's just, what, 16? So this becomes 7 times the 5th root of 3 times 2 to the 4th over the 5th root of 2 to the 5th. The 5th root of 2 to the 5th is just 2, because the 5's cancel each other out. And in this radical, I have 3 times 16. So this is 7 fifth roots of 48. Got to keep in mind, you've got to match that index with that exponent underneath. We're now going to move over to, and this is where we use it most of the time, by the way. It's not so much the one-term denominator as it is the two-term denominator. And that's where you have 1 plus the square root of 3. And if you wanted to get rid of the radicals, you're going to have to multiply it by square root of 7 minus square root of 3. This thing right here is called the conjugate. It's called the conjugate. And what the conjugate comes from is the difference of squares. A squared minus b squared is a minus b times a plus b. So if you take a look at it, what you're going to end up with is 7 squared minus 3 squared. It kills the radical because the inner outers add the 0. So we always say, we look at the difference of squares. This is a conjugate. Relationship. Conjugate relationship. Same numbers, different sign in the middle. Now, if I were to take the square root of 7 plus the square root of 3 times the square root of 7 minus the square root of 3. FOIL that. First is the square root of 7, square root of 7. Inner is plus square root of 3, square root of 7. Outer is minus square root of 3, square root of 7. And then last is minus square root of 3, square root of 3. I'd have the square root of 49 plus the square root of 21 minus the square root of 21 minus the square root of 9. Notice the two radicals add the 0. I'm left with 7 minus 3, and 7 minus 3 is 4. It kills the radical. Kills the radical. So this is what I want you to remember. If I'm doing a killing the radical and I've got a monomial in the denominator, one term in the denominator, you use one term to get rid of it. If you have a binomial denominator, you're going to use two terms to get rid of it. Two terms kills two terms, one term kills one term. So it's 1 on 1, 2 on 2.